smartphones, laptops, electric cars, wind energy, and even modern medicine. What connects all these technologies? A secret ingredient hides within them. Invisible heroes, without which our world today would look completely different. We're talking about rare earth elements. The name sounds exotic, maybe even a little intimidating, but don't let that fool you. Their story is fascinating and their role in our daily lives is absolutely crucial. I invite you on a journey into the world of these extraordinary substances. Let's start with the basics. Rare earth elements, REE for short, are a group of 17 metals that are very similar to each other chemically. You'll find them here on the periodic table. But watch out, here's the first tricky thing. Their name is misleading. They're not actually that rare in the Earth's crust. Some, like cerium, are more abundant than lead or tin. The problem is something else. These elements rarely form their own rich deposits. They are usually very spread out, mixed with other minerals, and very hard to separate from each other because they are so chemically similar. It's this difficulty in concentrating and extracting them that makes them, well, economically rare and valuable. Imagine trying to find specific, very similar grains of sand on a huge beach. That's a good comparison. The story of how we discovered rare earth elements is as tangled as their chemistry. It begins in the late 1700s in a small Swedish village called Göteborg. There, in a local quarry in 1794, a Finnish chemist named Johann Gadolin found a black mineral no one had ever seen before. They later named it gadolinite. While studying this mineral, Gadolin separated out a new earth, that's what they called oxides back then. He named it Yttria after the village, but that was just the beginning. It turned out this one substance was actually a mix of oxides from lots of different elements that nobody knew about yet. Over the next few decades, chemists painstakingly separated out these ingredients, often naming them after the place they were discovered. That's why 4 elements, yttrium, terbium, erbium, and ytterbium, all get their names from that one little Swedish village. That's a kind of record on the periodic table. Where do we look for these valuable elements today? Although they are found all over the world, economically viable deposits are concentrated in a few places. The main minerals from which they are obtained are bastnasite and monazite. For decades, China has been the absolute leader in the mining and processing of REEs, controlling over 90% of global production. Today, the situation is slowly changing, and other countries such as Australia and the United States are trying to rebuild or develop their own production capabilities. The mining and refining process itself is extremely complex and unfortunately often harmful to the environment. It requires the use of large amounts of water and harsh chemicals, such as acids and solvents, to dissolve the rocks and gradually separate the individual elements from each other. This is one of the reasons why these elements, although not geologically rare, pose a technological and ecological challenge. Okay, but why do we need all these complicated metals? The answer is simple. They have totally unique properties that are hard to replace. They're like real-life tech superheroes. Take magnets, for example. Elements like neodymium, samarium, and dysprosium help make the strongest magnets we know. Without them, we wouldn't have small but powerful motors in electric cars, strong generators in wind turbines, or tiny speakers in our headphones, or even large hard drives. These magnets are at the heart of lots of modern gadgets. And what about the colors on our phone and TV screens? We can thank europium and terbium for those bright reds and greens. They work like special lights, changing UV or blue light into specific colors. Yttrium is super important for white LED lights. Let's keep going. Cerium and lanthanum are masters of making chemical reactions happen faster. We find them in catalytic converters in cars, which clean up exhaust, and in oil refining. Cerium is also used to polish glass super precisely, and lanthanum makes camera lenses work better. They're even used in medicine. Gadolinium helps doctors see more clearly during MRI scans. Neodymium and erbium are key for making powerful lasers used in factories and hospitals. Pretty impressive, right? This huge reliance on rare earth elements brings some serious challenges. First, geopolitics. Most of the mining and processing happens in one country, mostly China. This makes the rest of the world dependent on them. Access to these resources has become a piece of a global economic and political game. Any sudden limits on supply could stop the production of important technologies. Second, the environment. Like I mentioned, getting these rare earth elements is hard. and creates a lot of waste. This waste often has toxic or slightly radioactive stuff in it. Rare earth ores often have natural thorium and uranium. Managing this waste responsibly and minimizing the impact on the environment is a huge challenge for the mining industry. It's kind of a paradox. Elements that are key for green technologies like electric cars and wind power are obtained in processes that can harm nature. What does the future hold? The world of science and industry is working hard on solutions to these problems. First, the search is on for new, more diverse sources of rare earth elements and the development of more environmentally friendly extraction methods. Second, recycling is becoming key. Recovering REEs from used electronics, so-called urban mining, has huge potential that we need to make better use of. Remember this when you throw away your old phone. At the same time, research is being conducted on alternative materials that could replace rare earth elements in some applications, for example in magnets or catalytic converters. It's a technology race that aims to reduce our dependence on rare earth elements and lessen our impact on the environment. Rare earth elements may be hard to pronounce but absolutely essential to our way of life and the future of technology. They're a fascinating example of how seemingly insignificant substances hidden deep within the earth shape our world. They are both a blessing and a challenge. The next time you pick up your smartphone or see a wind farm, think about these 17 remarkable elements working for you behind the scenes. I hope this journey has been interesting for you. If you learned something new, give this video a thumbs up, subscribe to the channel so you don't miss out on more learning, and let me know in the comments what other scientific mysteries you'd like to hear about. Thanks for watching and see you next time.